Whoa, what just happened? Let's go back to the home. We're at gotomath.com. We had, what's it called? Electronic voice phenomenon, EVPs, EVPTs. Sound like I heard a ghost in there somewhere. Let's hit calculus. Let's go down to this section here. I know everybody's enthused about it. Whoa, what the heck is this x cubed? Yee, scary. Can I get a zero to pop up? Whoa, there's one, 0 to 9. We'll try that out. Anyway, let's write this down quickly. So this is going to be the last problem in this section. We're just kind of going through the procedures here on how to do this. I'm sure probably one will be on your test. I can't remember if I had one on my test. I do remember finding the derivative by the definition. Um, yep, old Ken Harrelson, the great old guy I had for, I'll never forget it. It was like 6 weeks after the test. I'm going to tell this story. I don't care. What's he going to do? Sue me? 6 weeks. It was about 6 weeks after I'd had the test. I went. I was studying for finals or something. I don't know. It was something like maybe it was 8 weeks. I was studying for the final exam. No, it was midterm, and I had a question about it, and took it to his office. And it turned out that he counted the problem correctly. Everything was correct. Well, the answer was actually correct. And it turned out that somewhere along the steps of getting the answer, he decided to count a point or two off or something. I got it wrong and decided to change my grade. I was just in there asking a question on how to, on a question about that problem. It was the actual test. Well, he decides that he missed something and counted a point or counted the whole problem wrong. I can't remember, but boy, let me tell you, I wasn't very happy about it. And ended up changing my grade, grabbed his grade book and changed my grade. Well, I wasn't very happy about all that. So I went to a friend of mine who, well, I won't give any names, um, was into some strange stuff, like this kind of stuff, and told her the story. And she said, "Don't worry, I'll fix that." And I didn't know what she did, be honest with you. she, she grabbed a piece of my hair and grabbed part of my lunch was a chicken bone or something. And guess what? He wasn't working there at that school much longer after that. So I don't know. I just, whatever. But let's get started here. We got delta x. Oh, Ken. Now, I liked Ken Harrelson. He was a nice guy, I'm telling you. If it wasn't for him, I probably wouldn't be doing this today. And I'm not kidding. Yep, him and a few other teachers. I don't know what happened to Ken. Anyway, we got delta x is equal to 9 minus 0 over n. And Ken, if you ever watch this video or whatever, I'll tell you that I've helped literally millions of people in mathematics all over the planet. And it is in the millions. I'm not kidding. So thanks to you. Think about what you have done, contributed. CI, this is right endpoint, right? Right endpoint. That's what we're doing. We're using right endpoint. We're going from starting at 0. We're going to add over a delta x and an I. And so we got 9n over I. Let's not talk any more about that. All right, let's plug this in. So we got the summation. We got a cube here. And cubes, well, they're not nice. No, it's not bad, I promise. So fc of I, our function here, which is 3x cubed, we're going to say 3. We're going to plug in 9n over I. Ken, I'm just kidding about the chicken bones and the hair and the star there. But I did have a dream that you were packing up your stuff and you left, and I did go to you and tell you that dream. And that is a true story. Delta x is 9 over n. Yep. In fact, I had two dreams, which was pretty bizarre. And then after I left that university, moved on to another university, continue the education, I came back to visit, and I said, "Where's Ken at? Ken don't work here no more." That was terrible. It really was. But I'm going to tell you, my dreams come true. Cubed, I cubed most of the time. So be careful if I have dreams about you out there. We're going to go ahead and take a bunch of stuff and take it out front here. We got some big numbers, it looks like. And I'm just going to plug those in. Plug these big numbers in. We got 3 times 81. Whoa, that is definitely not right. I thought that was a square up there. 9 cubed. Yikes. 729. I'm going to have to pause and erase that. We had to pause at the pause of the big hairy beast. And of course, that's a completely different subject. 729. 9 cubed, n cubed, can't get that wrong, I cubed. And so we're going to take this 3, we're going to multiply it by the 729, and then multiply it by the 9. So let's do that. So we have 3 times, and I know you're going to do that in your head because I'm not. Whoa, my God, what year is that? That's a big year. So we end up with, wonder what it's going to be like in the year 19,683. Will man still be around? Probably not. 9 to the 4th power, right? We got 9, or 9 to the 4th power. We got n cubed times n is n to the 4th. And we're pulling all that stuff and getting it out of the way. Alright, getting it out of the way. I cubed. Alright, that's supposed to be a 3 there. Well, here's the deal. The kicker is, what is I cubed? So we've gone through I squared. We've gone through I first, summation of I squared. And now we got the summation of I cubed. Oh my gosh. What should I do? Write it right here? I don't know. 683 over n to the 4th times, and can't remember that one. I'll have to cheat on that one. Let me look. Okay, I looked. Ugh. N squared. It's n squared times n plus 1 and squared over, whoa, that was not a good line, over 4. Alright, so we got that? I hope so. We're at 8 minutes now. 8 minutes. Everybody has said forget it. They headed to the brew pub. Talking about that big W they're going to get tomorrow. No, actually it's too late in the semester. This is like a November the 24th. Too late for that. Well, what can we do here? Poof. Ooh, we got to fool that thing out. We can actually simplify some stuff down here. You know, I hope 4 goes into the year 1900, 683. What kind of internet will we have then? I'm just wondering, man. Hard drive space be like quadrillions divided by. It is interesting. I wish I'd be around for that. I'm afraid computing that far into the future won't be anything like computing today. I highly doubt it. That's not going to simplify down, so forget it. Just forget that. This will simplify. We got 2 ends up here, 4 down here. Let's just get rid of some of them ends. What will computing be like? 19683 over 4 n squared. We got this. We still got this to deal with. I shouldn't have wrote that. Let's try to convert that into nothing. I forgot. I was actually doing that right the first time. Squared. What we're going to need to do here is go ahead and full this stuff out. This is actually not going to be too bad, believe it or not. It's not too bad. 19683. I'm a little concerned though. on a few different things here. It looks like too big of a number. N squared plus 2n plus 1 if we multiply all that out. Yeah, I'm a little concerned about it. I gotta make sure I wrote down everything right. N squared times n plus 1 quantity squared. Yeah, that's right. If you distribute this number across, okay, and remember we're taking the limit of this thing, and so we're looking at the leading terms. And so really the only thing really to look at here is 19683 n squared. Oh my God, what was that? 4n squared. This is really the only thing to look at, okay, when we're doing this, because the leading terms are the ones we're looking at. You know, you distribute this to here and then to here. I mean, big deal. So this 19683 divided by 4, I am really holding my breath on this one. 4920. I hate to have to do this video again. Take 2. 4920.75. Right? You just take these two, you know, I'm just like, is this really going to be happening? Well, it is a cube though. I got to remember that. 19683 divided by 4. Wow, I want a standing ovation on that one. It looks like that's correct. So there you go. I shouldn't have probably wrote that in the decimal form, but I did. But anyway, if you know, you can understand this. If you multiplied this across, okay, it doesn't matter because we're taking the limit as n goes to infinity. The rule is look at the ones with the leading coefficients, or the leading terms, which is the ones with the highest powers, n squared, and then you just take their coefficients over each other. That's the fast way of doing that, and there you go. So we did it, and we did it under 15 minutes this time, but there it is. Okay. So you want to practice. I only have 4 of these problems. It's probably enough to give you a headache. Think about withdrawing from the course, but it's not too bad. Thing of it is you got to remember, you know, to take the limit. You got to remember the sum of sum of I squared, sum of I cubed. Got to know those guys, what they're equal to, and then remember that rule for taking infinite limits, or limits to infinity, I should say, or whatever it is. I always forget what the heck that is. Limits to infinity. That would be this section right here if you've forgotten how to do that. And really it's what problems is it? This one here, right, when their coefficients are the same. Okay. All right. Anyway, okay, come on over to gotomath.com if you're bored. Practice your problems. I can promise you I can get you through Cal 1 if you just practice. Practice. I can get you through. You won't retake that course. Have to spend $600, $700, $800, $900, $1,000. Maybe it's free. I don't know what you're doing out there, but I can promise you this: if you're at a college somewhere, you are paying big bucks probably. Maybe you're on a scholarship, but you don't want to lose that scholarship. So come on over, practice. I got tons of problems, and actually I'm doing all these this week. Hopefully I will be finished this semester. This is 20, or this, what is the date here? Let's go ahead and say it. It's 11/24/2014. That's when this video was made. All right, I got lots to say, man. I'm going to be doing all kinds of stuff. We're going to be doing algebra after I get done with calculus. Then we're going to be working on trigonometry. I just started these sections, and if you're in calculus, you probably don't need to see this stuff anyway. But anyhow, and hopefully I'll be doing Cal 1, 2, and 3, adding statistics, finite, discrete, all the engineering courses, physics courses, chemistry courses. Man, I'm just going to be going crazy. All right. So there it is. I can do it, and you can get through it and get out there and get a job. Or maybe you're just bored in life. Who knows? All right. See you later. Bye.